Second is cooking gas. Main ingredients of cooking gas is propane and butane. Molecular formula of propane is C3H8. Again, it is an open chain hydrocarbon, propane. And how to calculate this molecular formula? There are 3 atoms of carbon, that is why 3 into the atomic mass of carbon, that is 12, plus there are 8 atoms of hydrogen, that is why 8 into 1, that is atomic mass of hydrogen. So this will result into 36 plus 8, that is 44. So the molecular mass of propane is 44. That of butane, C4H10, that's molecular formula. Then the calculation will be somewhat like this: 4 into 12 plus 10 into 1, which will give us 48 plus 10, that is 58. So this is going to be the molecular mass of butane. Then benzene, C6H6, 6 into 12 plus 6 into 1, that will give 72 plus 6 is equal to 78. Then camphor, C10H16O, 10 atoms of carbon into the atomic mass of carbon, plus 16 atoms of hydrogen into atomic mass of hydrogen, that is 1, plus 1 atom of oxygen into 16, the atomic mass of oxygen. So that will result into 120 plus 16 plus 16, that is 152. Then penicillin is C16H18N2O4S, and this is how the entire calculation is going to be. There are 16 atoms of carbon, so that, and the atomic mass is 12, that is why 12 into 16 is 192. 18 atoms of hydrogen into atomic mass, that will give us 18. 14 is the atomic mass of nitrogen, and there are 2 atoms of nitrogen, that will give us 28. Then there are 4 atoms of oxygen into the atomic mass of oxygen is 16, so it will give us 64. Then there is 1 atom of sulfur, and the atomic mass of sulfur is 32, so it will give us 32. The entire calculation, or the total summation of all these numbers, is 334. So this is going to be the molecular mass of penicillin. So like this you have to calculate the molecular mass. And then I'll be teaching you now that how carbon can form single bond, double bond and triple bond. You can see that alkenes are the open chain hydrocarbons. These are the aliphatic hydrocarbons. Its general formula is CnH2n plus 2. So this alkenes will have a single bond between 2 carbon atoms. So this one is the smallest hydrocarbon or smallest alkene, that is methane, CH4. And then this is ethane. This is having 2 atoms of carbon, and they are connected together with a single bond, and there are 6 hydrogen atoms around it. So this is C2H6, and this one is propane, one of the ingredients of the cooking gas. Then it has 3 atoms of carbon into a straight line, and there are 8 hydrogen atoms around it. So this one is the propane. Now if we move towards the alkenes, these are the aliphatic hydrocarbons. Aliphatic, that means open chain hydrocarbons with double bond, and its general formula is CnH2n. Now this N stands for the number of carbon atoms. So if there are 2 carbon atoms, I will show you how the calculation is going to be. If there are 2 carbon atoms, then 2 plus H, 2 into, as there are 2 carbon atoms, 2 into 2 is equal to 4, and then this one is going to be C2H4. Then there is ethane, C2H4, with double bond between carbon and carbon atoms, and then there are going to be 2 hydrogen from this side, 2 hydrogens from this side, total 4 hydrogens. Then in propane, there is going to be, the molecular formula is going to be C3H6. So the structural formula is going to be somewhat like this. There is going to be presence of 1 double bond between 2 carbon atoms, like this. So this one is going to be propane. Then alkynes. General formula is going to be CnH2n minus 2. And this one is acetylene, the smallest alkyne. And this will have triple bond between two carbon atoms. And then there are going to be two hydrogen atoms around it. So this one is alkyne. This is acetylene. This one is propane. Molecular formula is going to be C3H4. So there's going to be presence of triple bond between two carbon atoms. One triple bond will be there into the entire chain. So this one is going to be the alkyne. So like this, there are alkanes, alkenes, and alkynes. Alkane will have single bond. Alkenes will have double bond, while alkynes will have triple bond.